Welcome back to the bedtime lessons. We are going to be doing 3 lessons. Not in this video. I'm only going to be doing 1 lesson in this video. It is about solar eclipses, and there are 3 parts in this video. The first one is a question like, what are eclipses and transits? Now, they are astronomical events where a celestial body partially or totally covers another celestial object. From Earth, we can see 2 types of eclipses: eclipses of the Sun and eclipses of the Moon. These occur when the Sun, Earth, and the Moon align in a straight or almost straight configuration. Astronomers call this a syzygy, from the ancient Greek word syzygia, meaning to be yoked together or conjoined. The term eclipse also finds its roots in ancient Greek. It comes from the word eclipsis, meaning to fail or to abandon. Eclipses, solar or lunar, have fascinated scientists and laypeople for centuries. In ancient times, eclipses were seen as a phenomena to be feared. Many cultures came up with stories and myths to explain the temporary darkening of the sun or the moon. In recent centuries, scientists and astronomers follow eclipses in order to study and examine our natural world. First, solar eclipses. They can only occur during a new moon and when the moon moves between the Earth and the Sun, and the 3 celestial bodies form a straight line: Earth, Moon, and Sun. There are between 2 and 5 eclipses every year. 5 solar eclipses every year. There are 3 kinds of solar eclipses: total, partial, and annular. There is also a rare hybrid that is a combination of an annular and a total. First, we'll look at total. It happens when the moon completely covers the sun, as seen from Earth. Totality during such an eclipse can only be seen from a limited area, shaped like a narrow belt, but usually about 160 kilometers or 100 miles wide and 16,000 kilometers or 10,000 miles long. Areas outside this tract may be able to see a partial eclipse of the sun. Looking at a solar eclipse without any protective sun eyewear could severely harm your eyes. The only way to safely watch an eclipse, a solar eclipse, is to wear protective eclipse glasses or project an image of the eclipsed sun using a DIY pinhole projector. Next, partial eclipses. A partial eclipse happens when the moon only partially covers the disk of the sun. Annular. Annular eclipse occurs when the new moon covers An annular solar eclipse occurs when the new moon covers the sun's center, leaving its outer edges to form a ring of fire or annulus. Hybrid. A hybrid eclipse is a rare form of a solar eclipse which changes from an annular to a total eclipse, and vice versa along its path. Now, lunar eclipses. The moon doesn't have its own light. It shines because its surface reflects the sun's rays. A lunar eclipse occurs when Earth becomes between the sun and the moon, and blocks the sun's rays from directly reaching it. Lunar eclipses only happen at full moons. There are 3 kinds of lunar eclipses: total, partial, and penumbral. Now we'll first look at total. A total eclipse occurs when the Earth's umbra, the central dark part of its shadow, covers all the moon's surface. Partial. When only part of the moon's surface is obscured by the Earth's umbra, we see a partial eclipse. And penumbral. A penumbral eclipse happens when the moon travels through the faint penumbral portion of the Earth's shadow. Planet transits. When a planet comes between Earth and Sun, it is called a transit. Mercury and Venus are the only 2 planets that can be seen transiting from the Sun and from Earth. This is because they are the only 2 planets in our solar system whose orbit is inside Earth's orbit. From the year 2000 to the year 2199, there will only be 14 transits of Mercury. Venus transits are rare, with only 2 this century, in 2004 and 2012. Wow. Our second part of this lesson is about. The next part of this lesson is a question. What can you see during a total eclipse? Number 1. The moment the edge of the moon appears to touch the edge of the sun is called first contact. Apart from a few brief minutes or seconds of totality, eclipse glasses must always be used for looking at the sun. The eclipse progresses. 1/4 of the area of the sun's disk is now covered by the moon. Obscuration at 25%. 15 minutes before totality, the temperature changes. As the moon continues to cover up the sun, the amount of solar energy reaching the ground decreases, causing a drop in air temperature. Shadow edges that are aligned with the sun's narrowing crescent start to become sharper. Edges that lie at right angles at the sun crescent shape remain more blurry. 45 minutes before totality, sharp and blurry shadows. 30 minutes before totality, sky darkens. With around 2/3 of the sun's disk now covered, the sky starts to become noticeably darker. 20 minutes before totality, temperature, humidity, and wind. Conditions on the ground and in the atmosphere continue to change as the amount of solar energy decreases. The moon's shadow can cause small changes in wind strength and direction. 15 minutes before totality, light level and colours. The surrounding starts to darken, while colours begin to turn greyish. The moon now eclipses more than 3/4 of the sun's disk. 10 minutes before totality, nature reacts. Night comes early. The behaviour of animals and plants start to be affected by falling levels of light. 5 minutes before totality, dark shadow on horizon. The moon's inner umbral shadow may become visible as it approaches from over the western horizon. 1 minute before totality, shadow bands. Faint waves of light, the result of turbulence in Earth's atmosphere, may be seen moving across the ground and walls. 20 seconds before totality, the corona appears. The solar corona, the outer part of the sun's atmosphere, normally hidden from view, starts to become visible. 15 seconds before totality, dark shadow sweeps. The moon's umbral shadow sweeps in from a western direction and envelopes the surroundings. 10 seconds before totality, diamond ring. The solar corona forms a ring around the dark moon, while the remaining silver of sunlight dazzles like a jewel. Eclipse glasses must be kept on for obscuring the diamond ring and Bailey's beads that follow. 5 seconds before totality, Bailey's beads. Just before totality, the final beads of sunlight stream through valleys along the edge of the moon. Now this will have to be the last one after this one. Totality begins. The moment the edge of the moon covers all the sun is called second contact. At this point, when the sun's disk is completely covered, eclipse glasses should be removed. The chromosphere appears. The chromosphere, a thin red layer of the sun atmosphere, may be visible for the first few seconds after totality begins. Prominences. Reddish tongue-like prominences may poke out from the sun during totality. These structures are supported by magnetic fields in the solar corona. Next, corona. It doesn't get completely dark during totality. The ghostly solar corona shines as brightly as a full moon. Totality, stars and planets. Stars and planets, including Mercury and Venus, may be visible in the darkened sky. Sunlight around horizon. Colourful skies may be visible in the far distance, around the edge of the moon's umbral shadow. Eclipse at maximum. The deepest point of the eclipse, when the sun is at most hidden behind the moon, this is roughly the halfway point. The features of the eclipse now repeat in reverse order. It is important to know how long totality lasts at a particular location. Before the outer edge of the sun reappears at the end of totality, Eclipse glasses must be put back on. End of totality approaches. It is important to know how long it is. In the final few seconds before the end of totality, the chromosphere may briefly become visible again. Totality ends. The moment the edge of the moon exposes the sun is called third contact. The eclipse switches from being total back to partial. As totality ends, Bailey's beads. A new set of Bailey's beads appear along the outside of the moon, signaling the start of the second partial phase of the eclipse. As totality ends, shadow bands, 5 seconds after totality. These faint waves of light may reappear for a minute or so, rippling along the ground and walls. 5 seconds after totality is the diamond ring. Bailey's beads come together to form another dazzling jewel of sunlight, with the solar corona again forming a ring around the moon. 15 seconds after totality. Dark shadow sweeps out. The moon's umbral shadow sweeps out, heading towards the horizon in an eastern direction. The ring of the corona around the moon disappears from view. The next opportunity to see it will be the next total eclipse. 20 seconds after totality, the corona fades. The ring of the corona around the moon disappears from view. The next opportunity to see it will be the next one. Dark shadow on horizon. The moon's umbral shadow may be visible in the distance as it retreats over the eastern horizon. 10 minutes after totality, nature returns to normal. Night turns to day once again. The animals and plants are going back to their usual patterns of behavior. 15 minutes, light levels and temperature. The condition of the sky and surroundings are returning to normal. Temperature changes are delayed slightly by an effect called thermal lag. 60 minutes after totality, obscuration at 25%. With around half an hour to go until the eclipse reaches its end, 1/4 of the sun's disk remains covered by the moon. 90 minutes after totality, the partial eclipse ends. The moment the edge of the moon leaves the edge of the sun is called fourth contact. Although the moon has finished at this location, the moon's shadow continues to travel across the globe from west to east. That's all for today's lesson. See you soon.